Comparison of radial distribution of eddy currents in aluminum disc in absence and presence of the skin effect. We studied aluminum disc with different radius and two fixed values of disc thickness. In the first case, the thickness of the disc is less than the thickness of the skin layer, and in the second case, the thickness of the disc is greater than the thickness of the skin layer. In the presence of the skin effect, in this frequency range from 3.2 to 12 MHz, the radial distribution of eddy currents changes significantly, and it's more difficult to theoretically calculate it. The radial distribution of eddy currents can be experimentally investigated using an installation for electrodeless measurement of the electrical resistance of metal discs and cylinders. To do this, aluminum discs were placed in the middle of measurement solenoid and measured the quality factor in a given frequency range from 3.2 to 12 MHz. The measurement results are shown in Figure 1. Figure 1 shows that the dependence of the Q factor on the frequency differs significantly for case of absence a skin effect and the presence a skin effect in frequency range evaluated, covers Q1 and Q2 respectively. Based on the obtained dependencies, the dependencies of the input resistance with the frequency is obtained, with results shown in Figure 2. In our previous work, it was theoretically shown that the input resistance is proportional to the square of the frequency in the absence of a skin effect, which experimentally confirmed by the curve R1. In the presence of the skin effect, the input resistance is directly proportional to the frequency, which is also experimentally confirmed by the curve R2. Figure 3 also shows the dependence of the applied attenuation of the frequency. Dependence of the input attenuation of the measuring solenoid on the resonance frequency for two cases. D1 with an aluminum disc with thickness when the thickness of the disc is less than the thickness of the skin layer. D2 with an aluminum disc with a thickness when the thickness of the disc is greater than the thickness of the skin layer. According to the theory, the applied attenuation is proportional to the frequency in the absence of a skin effect and proportional to inverse frequency in the presence of a skin effect, which is confirmed experimentally. To study the radial distribution of eddy currents in the disks, the dependence of the input attenuation on the area of the disk were experimentally measured, which are shown in Figure 4. Figure 4 points out that in the absence of the skin effect, the applied attenuation is proportional to the square of the area of the disk and has the following form. Formula 1. In the presence of the skin effect, the dependence of the input attenuation of the area of the disc has the following form. Formula 2. In the absence of skin effect, the inductance of measuring solenoid does not depend on the area of disc due to small thickness of the disc, while for thicker discs, where the skin effect is observed, the inductance of measuring solenoid depends on the area of disc. In Figure 5, we can see dependence of the inductance of the measuring solenoid on the area of aluminum disc for thickness when the thickness of the disc is greater than the thickness of the skin layer. To find the functional dependence of the inductance on the square of the area was constructed, which is shown in Figure 6. Figure 6 shows that inductance of the measuring solenoid at a frequency 12 MHz is proportional to the square of the area of aluminum disc and has the following formula. Formula 3. In the absence of a skin effect, the study of the radial distribution of eddy currents in the aluminum disc can be measured by measuring the dependence on the applied attenuation on the area of the round hole in the center of the disc. These measurement results are shown in Figure 7. Figure 7, it follows that this dependence has the following form. Formula 4. The general formula for calculating the applied attenuation for the aluminum disc for any radius with a whole radius has the following form. Formula 5. From the last formula it follows that then cutting a round hole in the center of the disc, the distribution of eddy currents along the radius of the disc remain unchanged. In the presence of the skin effect, the dependence of the applied attenuation is almost independent of the area of the round hole in the center of the disc. Indicating the location of eddy current on the edge of the disc in a thin region of skin layer thickness in a given frequency range, from 3.2 to 12 MHz. Thank you for your attention.